we can write the system of equations representing the amounts of gelatin, fish, and meat, x1, x2, and x3. The first equation, recall, is 10x1 plus 50x2 plus 200x3 equals 600. x1 plus 3x2 plus 0.2x3 equals 20. 50x1 plus 10x2 equals 200. We have the three equations here, but we've excuse me, made the left-hand sides into three rows of a matrix and the right-hand sides into three rows of an equal matrix. Now the three rows are going to be equal if the first row here equals the first row here, so that gives us our first equation, that this equals 600. Since the second row equals the second row, then this equals 20. Since the third row equals the third row, this equals 200. And we see that our system of equations is represented by this matrix product. If we look up here, we see that this left-hand side can be obtained as a product of two matrices. The first matrix, which we'll call A, is just the set of coefficients that you would multiply by x1, x2, and x3, the amounts of gelatin, fish, and meat, so that the first row is interpreted as 10 calories per unit of gelatin times the number of units of gelatin, 50 calories times the number of units of fish, and 200 calories times the number of units of meat. So that's the meaning of multiplying this row by this column, and of course the result is just this expression here, which is the left-hand side of the first equation. So what we're listing in the first row then is the amounts of carbohydrates, or the number of calories, the numbers of calories in the three different foods. The second row is going to then represent the number of units of protein in each of the three different foods, and the product will give us the second row here. And the third row will represent the amount of protein in the three different foods and give us the third row. Now if we call this matrix A our coefficient matrix, and we call this matrix X, then we have a matrix equation which we could represent by A times X equals B. So this matrix here is just the A matrix times the X matrix. AX, that's this one, that's this times this, equals B. To solve an equation like AX equals B, we would think of maybe dividing both sides by A, but as you've seen, matrix multiplication is more complicated than simply multiplying the numbers in the matrices. You have to multiply rows by columns, and it gets kind of tricky to figure out what you'd have to do to divide matrices. So let's think instead of multiplying this matrix, multiplying both sides here by the inverse of the A matrix. If we multiply A inverse by A, then we might get what we'd call an identity matrix. And an identity matrix times X should just give us X. So multiplying the inverse by both sides, on this side we get X. Multiplying a matrix by its inverse gives us the identity, which doesn't change things. On this side we get A inverse times B. If we could calculate that A inverse matrix, then we could simply multiply it by B and get X1, X2, and X3. Here's another model, just looking at how we represent some of these situations by matrices. Okay, H plus stands for the, well, H and W are going to stand for the numbers of wolves and hares in an ecosystem, let's say. H plus will be the number of hares after the transition period, W plus the number of wolves after the transition period. H and W, the numbers of hares and wolves before the transition period. Or if we wish to think of it, the present number of hares and wolves. Okay, so the number of hares after transition, we're going to say, is 1.2 times the number of hares that we have. This represents the fact that the hares reproduce, as we know. Hares are rabbits, and they reproduce rather quickly. So that in a transition period, the number of hares will increase by 20%, or by a factor of 1.2. and we end up with 1.2 times as many hares, provided we don't have any wolves. Now if we got wolves, they're going to eat some of the hares, so we're going to end up with fewer hares. We're going to subtract the 0.3W from this total, indicating that wolves are going to catch and eat some of the hares. Okay, the number of wolves after transition, well, we're going to say it's 0.7 times the number of wolves, and that means that the wolves would decrease if there were no hares. Because hares are an important supply of food to the wolves, that's a reasonable assumption. And if we assume that the number here is 0.7, this means that the number of wolves in a transition period will decrease to 70% of its present number if there's no hares for them to eat. But if there are hares, then we get to add 0.2 times the number of hares, which means that it takes, well, one hare will result in the survival of 0.2 wolves. It takes 5 hares to result in the survival of a wolf. These numbers aren't particularly accurate. I think the wolves are going to have to eat more hares than these numbers indicate, but these numbers are typical of the examples you have in your text, so we're going to go ahead and use them. Okay, now the question is, what do we multiply by the number of hares and the number of wolves to get the new number, the number after transition? H and W are the numbers before transition. This is going to be our H plus and our W plus, but written into the form that we have on the right hand side here. So what numbers do we have to put in here to get these numbers? Well, we're going to have a first row, and the numbers in the first row, the first number is going to multiply the number of hares, the second number is going to multiply the number of wolves, and it's going to give us 1.2H minus 0.3W. Well, that means that we're multiplying the number of hares by 1.2 and the number of wolves by negative 0.3. It means we're going to have to put 1.2 here, negative 0.3 here. And of course that's what we've got. Now don't look down here, but just look at the situation here and ask what we're going to have to do in the second row. You should pause and try to figure that out. Okay, now hopefully you've paused and tried to figure it out. This will be the number we multiply by the number of hares. Down here we'll have the number we multiply by the number of wolves in order to get the second row. And that tells us that 0.2 is going to be multiplied by the number of hares, so we're going to put a 0.2 here. 0.7 by the number of wolves, so we'll have 0.7 here. So that our matrix is as we see. And we can verify that this multiplication does give us the result that we see here.